Well, good evening, everybody. Well, I think it's quite in order that I would also like to extend my special thanks for organizers and the hosts for inviting me so that I can contribute to this very important event on UNESCO International Symposium. You will realize from the title that it's basically the study that was conducted in Namibia, but I'm from Dar es Salaam for the reasons that this is the work that was conducted by one of my students who is currently living in Namibia. And she was supposed to come and present, but she couldn't come for some reasons. What I'm going to talk here basically is to try to share with you the experience that we had in terms of applying one of method for assessing the river health as well as the water quality situation in Orange River in Namibia. And in this particular title, the thing that I would like you to draw into attention is about this what we call SAS. SAS stands for South African Scoring System. So basically is the system trying to assess the river health, and more importantly is on scoring aspect. That being the case, the structure, or rather the frame of my presentation is such that I've just got 4 points to talk. Number one, I would like to contextualize things, and then number 2 is share with you the approach that we used in applying this technique, that's SAS. And in a nutshell, the main highlights from the study and what is that we have as a conclusion. It's something that I don't want to dwell into much because I think throughout this morning, yesterday, today, it's very clear from the fact that for any given catchment, we have a number of development activities which are responsible for water quality deterioration, but as well the health degradation of the river. There's no exception with the Orange River in Namibia because we also have these development activities in this particular river, and one may wish to sum up all the development activities as land-use based kind of activities. In a nutshell, this is where we had our study, and like you can see, is that we had a number of sampling points all along the river. And from this particular map, you also see some of land use, including settlement, river itself, road, and also the location where settlements are, and more importantly, the irrigated area, or the activities where you have irrigation activities. These are the images which are just trying to portray different views with regard to Orange River in Namibia. You can see that this is the image trying to show the picture of the river during low flow season. But again, along the river, we have also got what we call informal settlement in a particular neighborhood called Oscar. Below here, you see this agricultural activity, mainly irrigation one, and the type of crops that are being grown, grape. Just like any other rivers, impoundment of water for some activities is also taking place in Orange River. In this particular case, the river is being regulated in the sense that there's a weir construction that is going on there, with the implication in the long run that the ecological system is going to be affected. Fears are arising in terms of pollution. That's because of the use of agrochemicals in terms of fertilizer, pesticides, herbicides, because the scale of agricultural activities are on rise. And like I'm saying, that the irrigation basically is on the flooding because we have about 50% of the irrigation is flooded. That accounts for about 300 acres of irrigated area, but also the future plans are that the irrigated area is going to be expanded up to 1,000. This is for Nodwell neighborhood. But also again, the other neighborhood, Onska, it has the area for irrigation about 2,000. And like I'm saying, we have the irrigation activities going on there. The other issue with regard to this river is the sanitation, that no information on how much wastewater is disposed in the river. But again, with regard to sanitation facilities, some places they're there, but in some places you don't have, therefore, inadequacy. Reports that are in place are suggesting the occurrence of eutrophication for drinking water treatment plants, but also the upstream of the river, which is in South Africa. And the other most important issue of concern here is the fact that the river is now under regulation in terms of construction of weir, which automatically is going to affect the ecological system. So these are the issues that are surrounding the Orange River, which one would broadly categorize that all the causes that I've just presented to you are basically arising from economic development as well as population growth. Therefore, we needed to do this study for only one major reason. Basically, we wanted to see how the river is faring in terms of the health. And here we try to use biological, chemical, as well as physical parameters. But also the other most important thing, we were trying to link what is about happening with regard to land use activities. This is the study that I've just explained to you. The river health was based on the assessment of the so-called ecological integrity. And like I said, we use the tool known as SAS, using bioassessment, a little bit of SAS. This is, like I said, is South African scoring system, and it was meant to do assessment of the health of the river. Some little bit details about the SAS. It is qualitative tool in the sense that subjective, because sometimes one may wish to use professional judgment in terms of the type of macrophytes that we have, using different types of habitats that we have in a particular river. It is a rapid field method. What is required in this particular technique is only the identification of macrophytes at family level. It is considered to be inexpensive technique for detection of water quality over periods. And also, it is basically for checking the ecological integrity. And throughout the literature that we had, there was no study that was conducted at Orange River using this method of SAS. In terms of sampling macrophytes, the protocol that was used, SAS protocol, that's the net size that was used. Most importantly was on the biotopes. We used 3 types of biotopes. The vegetation, both riparian as well as in-stream, or also the other biotope that was used was stones, whether they are in or outside the current. And the last biotopes that we used to get to the macrophytes were macro-invertebrates, was gravel, sand, mud. And that is the period that we had. Like I was saying, this was a master's student, and therefore we just tried to apply, and therefore we didn't have enough resource to do long-term measurement of the macro-invertebrates. However, there were 8 sites in total. We only used 6 sites because 2 sites lacked the habitat necessary for using this tool. And also we needed to complement the result that we have from the Department of Water Affairs, because already they had collected. But the most important thing is that we didn't have that continuity of data series in terms of macroinvertebrates. So even the result that I'm going to report were on a particular time. And like I said, the SAS is based on the scoring system. It's subjective, using professional judgment. One would just score anything from 1 to 15. based on the sensitivity score, but also the other most important thing, based on the macro invertebrates that were sampled, one would also establish the total number of taxa that were had. And therefore, we would also try to sum up the number of all the taxa that had been identified. We also needed to get one important parameter. This is called average score per taxa. You have total score for a particular habitat, and also you identify the total number of taxa, and then you need to get how much each taxa has scored. This is what we call average score per taxa. That is something that could be used using the framework that is coming there. So how would you now determine the health for a particular site? And here I must emphasize one thing. As far as the health assessment of a river is concerned, it's not just like you get the health for entire stretch of the river, but for a particular site where you did the macrophyte, macroinvertebrate sampling. I'm sorry, macrophyte is just coming, I don't know why. So once you have determined the average score per taxa, you'd also compare with total score for SAS, and then you'd also have the category ranging anything from A or to E. And that is where I would say what is the health of a river for a particular site. And this is an example that I would like to, the most important slide for me is this one and the following, because like I'm saying, the first thing you need to determine the average score per taxa, that is based on the score, that is on x-axis, that is on y-axis, but on x-axis, there is where now you have the total score for SAS. If, for instance, you get your ASPT, say 5, and if it happens your SAS score is 100, you need to just project this horizontally and that one vertically where they are meeting is where now you would just like to get the category of that particular aspect. So like I'm saying, you have anything from A to EF. But what is it that we have as interpretation for this category? This is also what we have in ecological categories, which is normally used for interpretation of SAS. So using ASPT and the SAS score, if you get category A, that indicates for a particular site that your river is natural, meaning that there's no any modification. So if, for instance, you get your ecological category F, that is what you're saying critically modified, and you have what we call critically modified is an alarming that something has to be done. And we also have the color coding in as far as interpretation of the SAS itself is concerned. Physicochemical parameters we analyzed using the normal method. We had those in situ parameters and the one that we needed to analyze in the lab. We, of course, the most important thing was standard methods were used for this particular case. The impact of land use on water quality, it was a little bit of remote sensing. And these are the procedures that we used, just getting the images for 2 different times, 2020, 10, 12. And also we do the processing that are normally carried out with regard to the remote sensing techniques. It's quite a lot of the procedure, so I don't want to go into detail for each particular case. Now, in terms of results, so how is it that we now determine the health of the river? So we had different times, and also we had different sites. So OR1, OR4, OR5, these are different sites where we sampled macroinvertebrates. There is one, for instance, for the period November, we had SAS score 64. The number of taxa that we had was 13, and the average score per taxa, that was about 4.9. Using the bands that I had, there is when I would say for this particular site, the river would categorize as in C, so fairly modified or something like that. So we did it for a number of sites that we had, and also for different times, and there's when I will just try to describe the health of the river. So summarizing is that when you see you have low SAS score and ASPT, it is the indication that you have dominant pollution-tolerant families, meaning that in a way the river has been polluted. You only have families of some organisms or macro-invertebrates that are able to tolerate that level of pollution. And also in some areas, sites, they are very sensitive families. That's because of the nature of the site, which was not heavily polluted. It's also not bad that in as far as macrophyte pollution indicators, we have you have what you call pollution indicator, and also the type of pollution there are. For instance, if you see an increased ratio of worms, stoneflies, maggots to insects, is saying that you are now having nutrient enrichment. So it goes all the way down where you have reduced community richness, an indication that the type of pollution there is heated effluent. With regard to the physical chemical parameters, we'd like to run you through because there's one slide which is summarizing everything. But it's sufficient to say that for different parameters, there was both temporal, spatial variability in terms of this physical chemical, because like you can see, this was the distance from the upstream, it goes all the way to downstream, and you see you have different parameters, different values for temperature for different period of time. But interesting to see for temperature is that for period 2013, February, there's now you see the temperature was highest for all the sites. So it goes for conductivity as well, where we had here that for period 2012 November, the values for conductivity were recorded to be the highest, and the other values as can be seen there. pH as well, we had the highest values recorded for 2012 December, and the rest of the values are as indicated. We also have... Okay. The slides, of course, we had a number of these parameters: turbidity, total dissolved solids, dissolved oxygen, total phosphorus, total nitrogen, chlorophyll A. And this is the slide which just tried to summarize, because at the end of the day, despite the fact of recording of these values, we are interested to see whether these values are within or outside the standards. And here we used 3 standards. The Namibia has already got the guidelines for water quality, and also we use South African standards, and also United States Environmental Protection Agency. Through looking at these particular slides, you realize that there were only 2 parameters which were above the standards, and that is turbidity. We needed to have the mean concentration for turbidity for the whole river, and also chlorophyll A. But the rest of the parameters, they are within the standards. The influence of land use activities, water quality, we see that from 2002 to 2012, there was no significant difference in terms of increase in acreage for irrigation, because for 10 years, there was a difference of only 38 hectares, not much. And here's where I would see the land use for 2002, where the total irrigated area was 3,500, and the land use for 2012, the irrigated area was 37, neighborhood 3,700 for. So in conclusion, we are saying the bioassessment method using SAS is telling us that the river, Orange River, is in category C, suggesting that the river is a moderately modified system with fair water quality. In terms of spatial variability, we wouldn't see it to be that much significant. though there was significant, but I think the variation was less. Physical-chemical parameters that were tested, they are indicating the quality of water is still fairly good, though some slight levels of deterioration are being observed. Although there was no major changes observed in land use activities, especially agriculture, the slight water quality changes detected in the river could be the result of combined effects, land use as well as low flows, which is the natural phenomenon that is normally occurring in the river. Therefore, the study that we conducted could not be able to establish whether the land use activities alone in the study had the influence in the water quality. This is all what I want to share with you. Thank you very much.